this. We are reviewing for our unit test, and so far we said that this quadratic will be down like a frown, not particularly wide or narrow, and we are now just finding the vertex. So we did negative b over 2a, we got out 2.5, and now we are just going to use our calculators to plug in 2.5. Can everybody do me a favor? Does everybody have a calculator? You're going to need one if you don't have one. Everybody go ahead and plug in 2.5. I have a feeling that some of you are typing it in the calculator incorrectly. So everybody please get an answer for plugging in 2.5 back into that original. And we're going to see what answers we get out. Do you have a calculator? We should not be using our phones as calculators because you can't do that on the test. So let's make sure that we can use these calculators and we know what we're doing. So plug in that 2.5 and see what you get out. When you start getting some answers, tell me. Lily, what'd you get?
1/4 or 0.25.
0.25. What else have people gotten? There's no way in the world everybody got the same answer. I'm telling you that right now. Someone got something else. Kristen, you got something else? Oh, you did? Yeah. 4. Anybody get something other than 0.25 or 4? I don't know what the answer is, so I'm not sure what's correct. Everybody got either 0.25 or 4? Oh, sorry.
Is it right?
I don't know. I don't know what the right answer is. Okay. It could be. I don't know. Gianna, what'd you get? You got one of these?
I believe my answer because I knew it was wrong.
You did? Okay, so we're going to find out the right answer, but here's what I need you to know. I need you to know how to type a problem like this in on the calculator the right way, because the calculator will do the work for you. So as long as you type it in the right way, you're going to get the right answer. So look at your quadratic here. See, it says negative x squared.
It's the opposite of x squared.
Right, I'm going to replace the x with whatever I'm plugging in. That negative is still there. And remember, guys, there's a difference between the negative key and the minus sign. They're different. Negative is underneath the 3 on my calculator. I'm probably on, I don't have a scientific in front of me, but I think it's the same thing. And then minus is over here with the, they're different. So if I want to do negative x squared, I'm going to hit the negative button first. So see, I have a little negative there. Let me clear this out. Negative. And then, since I'm plugging in a negative number, you have to put it in parentheses. You have to. So parenthesis. And then what are we plugging in? Oh, I'm not plugging in a negative number, but whatever. All right, so I don't need the parenthesis, but it's not a bad thing to have it. 2.5, and now I want to square 2.5. Plus 5 times 2.5 minus 6. 0.25. So that is correct. So now I know where my vertex is. It's at 2.5 comma 0.25. So it's teeny tiny right there. It's going to be kind of hard for me to do the pattern since my vertex isn't at a nice point. So why don't we just go ahead and plug in some numbers. If I plug in 1, I mean, that I can probably do in my head. I don't have to have the calculator to do that. But wouldn't that be for negative 2? If you plug in 1, you get out negative 2? Do you agree? Buy 1, get 1 free. If I plug in 0, I get out negative 6. Buy 1. Get 1 free. Okay, so there's enough points for me to make my parabola. Just be careful with that vertex is just over the top there. Bloop. Okay, so now I know where my vertex is. So there's the answer to part B. 2.5, comma 0.25. I also know the axis of symmetry without doing any more math. Yes, it's always x equals whatever the x-coordinate of the vertex is. We already answered that. I know the answer for E. Max. Does everybody know why it's max?
Down.
Yeah, if your parabola is down like a frown, the vertex is the highest point on the whole graph. It's the maximum point, so it's called a max. If your parabola was up like a cup, the vertex would be the lowest point, it would be a minimum. So anyway, that's a max. Let's skip to H right now, because that you know how to find. Y-intercept, I can look at my graph and see it, but how do you normally find Y-intercept? You plug in 0 for x and see what comes out. I already did it, and that's how I knew I found that point on my graph. But if I didn't graph it, I would just plug in 0 for x. Now, so these three things that are left, you've done this a billion times. We just haven't done it on the graph. Domain and range. Do you remember what they are from way back when? Yes, domain is all your x values, range is all your y values. So basically, if you look at the parabola, right? See how this side is going to continue to go towards the left?
Oh, it's the thing to like negative infinity and positive infinity, right?
Yes. Yeah, you can do it that way. So this is going to go, see, okay, my x values that are covered. See, I have an x value for 1, for 4, for 0. Aren't I eventually going to get an x value for all of these? Forever? Because this is just going to keep going this way forever and ever and ever and ever and ever and ever and ever. And it's going to go this way forever and ever and ever and ever and ever and ever and ever and ever. So basically, this graph will eventually cover the entire x-axis. I'm just going to have really big numbers, but that's okay. Now, look at the y values. No matter what you plug in for x, you're going to get a number down here. Are you ever going to get a number up here? No. This parabola never goes up here. Never ever. So the y values are only going to be from your highest point down. That's the range. So the domain is actually easy for parabolas because it's always all real numbers. Always. Because the parabola is going to keep going towards the left and towards the right forever. So for domain, every single time you see it, you're just going to write x equals all real numbers. That R, capital R with the double line, just stands for all real numbers, if you didn't already know. So, am I going to ask you that tomorrow? Yeah, and that's what you're going to write every single time. You don't even have to think about it. Domain is always all real numbers. Range is a little bit different. Range, the highest y value I'm ever going to get is right here. And I'll get everything below it, but I'll never get anything above it. So, what does that mean? My range, my y values, will always be less than or equal to, does anybody know? What number's going to go here?
Negative infinity.
No. I'll give you a hint. There's no more math to do. You already have it. It's already on your paper somewhere. 0.25. The highest y value I'm ever going to get is 0.25. So that's the highest. All the other y values are going to be something less than 0.25. Does that make sense?
Yeah.
So for the domain, that's a free point as long as you remember to write x equals all reals.
Is that always?
Always. As if you're graphing parabolas, that is always true. And all you're graphing tomorrow's parabolas. I'm not going to sneak on some weird thing. So, all real numbers for parabolas. And then your domain is always, now, it could be it could be greater than or equal to, depending on if it's up or down. So when we graph number 2, we'll talk about that. But it's always y, and then the y coordinate of the vertex.
So y is less than or equal to, and then
If it's down. If it's up, then it's going to be y is greater than or equal to. So it's just what y values am I getting? I'm getting all the y values less than 0.25. I'm never getting y values greater than 0.25. All up here, you're never going to get that. Okay, now the x-intercepts. You've been finding x-intercepts for forever. How do you find them? When you do blank with a quadratic, you are actually finding the x-intercepts. What goes in that blank?
Solving?
Yes, when you solve a quadratic, you are finding the x-intercepts. How do you solve a quadratic? Oh, you have 4 ways. Square rooting, completing the square, quadratic formula, or factoring. So I just got to go up to this guy, right? I'm trying to find the x-intercept, so wouldn't y be 0?
Yes.
So I'm just going to take this guy, plug in a 0 for y, and now I am going to solve it using any one of my methods. So if I were you, I would try and factor this thing. A is not 1, it's -1, so why don't I just divide everybody by -1? Make my life easier. Are there factors of +6 that have to be -5? Bless you. -2, -3, you got it. So that means my x-intercepts are actually at 2 and 3. Look at your graph. Doesn't it look, I know I've drawn all over mine, but look at your nice graph. Doesn't it look like it's crossing the x-axis at 2 and 3?
Yes.
Yeah, so that's absolutely reasonable. 2 and 3.
Can you go back to the graph or something?
Sure. Mine's gotten a little,
How'd you find the first point of, oh, you went 1 over. 2.5. From 2.5, would you go to 1.5?
I plugged in the number 1.
Oh.
I would have followed my pattern if my first point was like a nice vertex. Like on number 2, I'm going to follow the pattern because it's a nice vertex. All right, so
Did you get 1, -12?
no, when I plugged in 1, I got out -2.
Okay.
All right, so let's check out the second one. The second graph. Tell me what you know about this graph before we even start. It's up like a cup. So that's the answer to D. Okay, got it. Tell me something else you know. You know where the vertex is because this is in vertex form. -3, -2. There's no work to do for this one. -3, -2. Which means once I have the vertex, I already have the answer to the axis of symmetry. That's just, you have to write x equals. Yep, you have to write x equals -3. You kind of have the range, but I'd rather graph it first before we fill that in. Yep, you will be able to tell that it's a minimum because we already said it's up like a cup, so you have a minimum. All right, great. So now I have a place to start, -3, -2. 1, 2, 3, 1, 2. Okay. Now, what's the value of A? 2. So we can use that pattern. That value of A does tell me how to get to my next point. I just go up 2 over 1. Buy 1, get 1 free. Bless you. So now, to find my next point, I'm going to plug in either -1 or -5. What would you rather?
-1.
Me too. So you can either ask Mr. Calculator to do the calculations for you, or if you're confident enough that you can do it in your head, that's fine. Just make sure that it's right. So if I plug in -1, I get 6. Did you? By 1.
What did you plug in?
I plugged in -1.
How did you get 6?
-1 plus 3 is 2. 2 squared is 4 times 2 is 8. 8 minus 2 is 6. If you're not sure, then have the calculator do it. You don't have to think about anything, right? If I want to plug in -1, 2 parentheses, -1 plus 3, close parentheses, square it, minus 2. It'll do all the work for you. And I might as well go ahead and plug in 0 because I'm going to have to anyway because I have to find the Y-intercept. So normally I'd stop, but I have to do it anyway. So let's just do it right now. So if I plug in 0, this number's going to be pretty big, huh? 9, 18, 16, which is off my grid probably. Just one off. I get 0, 16. There's my gorgeous parabola. So the Y-intercept, we found it was 0, 16.
I only had to have 5 points.
Correct, but I need the Y-intercept anyway, so I just did one more point. So now I have a whole bunch of information. I know the x-intercept without even doing it, right? Because it came out really nicely on my graph. I can just look at my graph and it tells me where the x-intercepts are, right? What are they?
-3 and -2.
-2
Yeah, -2
and -4. Because it crossed perfectly. I couldn't do that on the last one because it didn't, well, it might have crossed perfect, but I didn't really know that. I didn't have a dot on there. You get what I'm saying? I had dots right here. So I know it's crossing the x-axis at -2 and -4. Oh. So my x-intercepts are -2 and -4. Remember, squiggly brackets, because I'm just listing, hey, here's all the places that it crossed the x-axis. Did you hear I said crossed? Wow. Whew. It's been a day already. It's not even barely 8 o'clock. Crossed. And I'm well educated. Crossed, I said. Oh my gosh. Anyway. So, squiggly brackets, because I'm literally just listing. I could have put -4, -2. Order doesn't matter, right? I'm just listing my answers. Here's all the places across the x-axis. Okay? So all we have left is domain and range. You know the domain already. It's just x equals all reals. That's all you write every time. You don't even need to think about it. And then the range, well, it's not going to be equal to. I'm going to get y values that are, the lowest I'm ever going to get is -2, and I'll get everything above it, right? So y is going to be greater than or equal to -2.
How did you get the x-intercept?
And this one you can just look at the graph. See how I can tell it's crossing the x-axis at those two places. If I didn't get it, I would set y equal to 0 and solve it. I'm going to do that anyway. Why not? So I'm just going to show you. If you were going to solve for the x-intercept, if you can't tell from your graph, because you got to know exactly where it is. You can't be guessing, right? So you can plug in 0 for y. X plus 3 squared minus 2. Does anybody remember how to solve one like this? The easy way. Don't go the hard way. If you're thinking, oh, I should FOIL that out, you're already doing too much work.
How can you see it?
Just turn it on paper and I'll grade it by hand. Anybody remember how to, what would you do with this to solve it? We actually learned this the very, very first day we did solving quadratics. So long ago.
Oh, is it -3, +2 for the vertex?
It is. Well, it would be -3, -2 for the vertex. But I want to solve this thing. I want to figure out what x equals. Guys, you're going to get the thing that's being squared by itself, remember? Add 2. Divide by 2. Now what? Something's jumping out at you, right? Now you're like, oh yeah, of course, I can just take the square root of both sides. The square root of 1 is positive and negative 1.
Wait, why is 0 plus 2 over 2?
It wasn't. It was 2.
Yeah.
And then I divided both sides by 2.
Oh, okay.
Now I'm here, and now all I have to do is minus 3. So now I have negative 3 plus minus 1. Negative 3 plus 1 is negative 2. Negative 3 minus 1 is negative 4, just like we thought. So if for some reason you can't tell where your x-intercepts are from your graph can always give you an estimate, right? I always know about where they're crossing. So if you want to make sure, you can solve it, and there's your exact answers. But I already knew that they were there. Do you want to try number 3 by yourself? But I want you to answer all the same questions, A through I, for number 3.
Miss Evia?
Yeah.
Going back to number 1, I started it on myself. And for the vertex, because it's negative 5 over negative 2, how would you make that look? How would you
You just divide it into a decimal, so we had it as 2.5.
So it would be negative 5 divided by negative 2.
Mm-hmm. Okay, so everybody try number 3. Give me the answers for A through I for the same thing, and give me the graph. Notice that this one's an inequality, so things are going to be a little scotch different here. Okay, try it. I gotta learn how to pause a video without stopping it. You think there's a way?
There might be, I don't know.
Anytime I've tried, it just stops it. Alexa, pause. It works at home.
I want to get the light that is powered by Alexa, because I have like one lamp in my room.
Oh, that'd be nice.
They like glitch out. Sometimes they don't like with them, but my dad can calm down because every time I'd say it, like all the lights would either turn on or turn off.
Oh, the lights?
Yeah, it's just so
Yesterday I was FaceTiming with my mom, and I was talking to Alexa, and hers were going off. It was funny. How do I
My
pause
dad gets
this?
freaked out because he'll be watching like a video on his phone, and it will say like he doesn't have an iPhone, so I don't know what his brand is, what you say, but it will say like something like that on the video he's watching, so Axis isn't it on his phone.
Oh, weird.
Like it will say like go to settings on like a video, and then his phone will like go to settings. It's like he gets so freaked out by it.
Gosh, there's no... You would think that there's a pause button. Let's try this one. No. If you have no idea what to do, you can always at least make the graph. Even if you don't know where to start, just start plugging in numbers. Plug in 1, plug in 2, plug in 0, plug in negative 1. The calculator can do all the work for you. You just don't get to buy one, get one free. You only get one dot at a time. But eventually, you'll have a picture of the graph. So hopefully, if you already have the picture of the graph, then how easy is it to find the vertex? Super easy. So if you blank out tomorrow and you're like, I don't remember how to find the vertex.
School is weird. You know the teacher that drags on the hoverboard?
Yeah.
He came out of the elevator and then I went over. When I was waiting like to go in the elevator, like he was just eating out on his little hoverboard.
Did he know that he ran you over?
He was, you like went out really fast, like right as the doors opened up.
Okay. Oh, sorry.
Okay.
Yes.
The vertex -4, -12. Yeah, that's right.
That sounds right. -4 is right. And then let me plug it back in. You'd get 8 minus 16. -12, yeah.
How'd you get the -12? I got the -4, but
So now you plug -4 back in.
to the equation.
Mm-hmm. Mm-hmm.
Yours is still recording, right?
Mm-hmm.
Oh, okay. Well, when you do the, like, when you're graphing, find, like, the next two points, that's like a vertex. When it's a half, do you go half of the square and half of the square?
Yes, you do not go up 1 square over 2 squares. That's totally wrong. But you can go up half a square over 1. That's fine. At least 5. Always 5. Vertex, and then 2 more buy one, get one frees.
So you go up half and then over.
Mm-hmm.
When you do the y, can you get the buy one get one free on the y or no?
For the Y-intercept? Sure. Sometimes that's nice because that can be like a free point.
What about like number 1? So it's a negative x. So would you go down? Would you go down?
Well, you would normally go down 1 box, over 1 box, but since you're not starting at a nice point to begin with, I mean, you can, but I would just plug in the next number.
This is what my graph looks like. Should I do more points or am I good?
Oh, that's fine.
Okay.
Okay, guys, are we ready to start talking a little bit about this? Can you tell me what this is going to look like? Up and
It's gonna be narrow.
narrow. Yeah, and we should have talked about it. If you compare your first and second graphs, isn't the second one clearly more narrow than the first one? If you compare the two? Right? So now when I graph number 3, it should be wider than both of them. Okay? So I'm expecting a somewhat wide, up like a cup graph. So that's such a quick check. Before you turn in your test tomorrow, just go back and make sure every graph that you thought was supposed to be up like a cup is up. Every graph that was supposed to be down is down. I cannot tell you how many times, even Algebra 2, they do the same ones. Someone will turn into me, number 1, up like a cup. I'm like, you know that's wrong. Right? So just make sure that such a quick check, right? And it'll save you some points if you have it messed up. So I ask you to find the vertex. So the vertex on this, -4 over 2 times a. 2 times a half is just 1. So hopefully you got -4 comma something. Yeah? if I take -4 and I plug it back in. Your calculator can do that for you if you want. So 1/2, oops, you can do 1/2 as 0.5 or 1/2, it doesn't matter, times -4 squared. Now listen, if I'm plugging in a negative number, you have to put it in parentheses. -4 squared plus 4 times -4 minus 4. -12. Did all the work for me. So as long as you type it in correctly, you should get the right answer out. So -4, -12 is my vertex. I do have 12. I will fit on this graph. 1, 2, 3, 4. 12. Oh boy. 4, 8, 12. Okay, there's my vertex. Now we can follow the pattern if you want. This is so important though. Please listen. From that vertex, you cannot go up 1 over 2. That is 100% wrong. You can go up half a box over 1. So you get this little tiny point right here. Buy one, get one free. That's fine. Now, maybe I'd plug in probably -2 instead of -6. But that's up to you. So if I plug in -2, again, I can ask my and actually, if I don't want to retype everything, do you know this little trick? You hit second enter and it brings up the last thing you did. So now I can just change these to -2s. I don't even have to retype it. Look at that. What fun. So now I got -2, -10. -2, -10 would be right here. Buy one, get one free. Alright, I might as well do my Y-intercept too, because I'm going to need that anyway. If I plug in 0 for X, what comes out for Y?
4.
Mm,
That's your one goal.
-4, yeah.
Sorry.
So now I have plenty of points for my...
What was your
What was the what?
What was the
0, -4. Alright, so let's fill in all of our blanks here. Make that a little bit better. Okay. So let's see. The vertex was at -4, -12. The axis of symmetry is at x equals -4. Up or down? You guys said it was up. Is it a max or a min? Min. The domain? X equals all reals. The range, y is, yes, greater than or equal to -12. That's all the y values I get out. The smallest one I get out is -12, and I'll get everything above that. So y's are going to be greater than or equal to -12. The y-intercept, we found it. It was at 0, -4. And the x-intercepts, I don't know them. My graph, I have approximates. So one looks like it's going to be close to, I don't know, 1 or 2. And then this one's going to be negative, I don't know how far out we are, but some. Right, so I have to do the work because I don't know exactly where they are. I have approximates. So I'm going to plug in 0 for y and I'm going to solve it like it's a normal quadratic. And I know how to solve these because I've been doing them for months. I know I have 4 ways. I can solve by square rooting, factoring, completing the square, quadratic formula. Now, I know that you see a half there and you don't like that.
Multiply everything by 2.
Sure! I can multiply both sides by 2 here. Multiplying 0 by 2 doesn't change anything, right? So I just still have a 0 and then I get x squared plus 8x minus 8. You gotta multiply everybody by 2. Okay. Are there factors of -8 that add up to be 8? I don't think there are. So you're gonna have to solve it another way. So what do you want to do? I would complete the square, and that does, I'm just going to write the equals 0 on the other side because I can't stand it on the left. I'm going to complete the square here because A is 1 and B is even, so it should be pretty easy. If you don't like it, do quadratic formula. If you remember it.
Yeah. What is it? Half of B and square it.
Yeah, so this way, you move C to the other side. Now I have to figure out what that magic number is. Half of B squared. 16. You add 16 to both sides.
Wait, why do you get rid of the negative?
You gotta move C to the other side, so that's step 1. Half of B square it, so 8 and 16 is 24. On the left, you just factor that. Factors of 16, they have to be 8. 4 and 4, but you write it as x plus 4 squared. And then I am going to rewrite this over here because I'm running out of room. X plus 4 squared equals 24. Okay, so once you get here, now what do? Now you square root both sides. Square root u, square root u. 24 is not a perfect square, but what is? I'm going to split it up into 4 and 6. Right? Because 4 times 6 is 24, but 4 is a perfect square. So I really get 2 root 6. But I need to remember plus minus. And then all I have to do is minus the 4. You don't have to do that out. If you really wanted to and you wanted to figure out what those two decimals are, you could. I don't need you to. That's your answer. You would just write x equals, funny brackets, negative 4 plus minus 2 root 6. Those are the two places where it's crossing the x-axis. They're just not going to be nice, clean points. They're going to be some crazy decimal. One's going to be pretty close to 1, and one's going to be some big negative number. Mm-hmm.
How would you find the domain and range?
Domain is always x equals all reals. Always, no matter what. So that's kind of a free point as long as you know to write that. And then the range, so for this particular one, range is your y values. You're only going to get y values from here up. You never get y values down here. This graph is never going to come back down and go down here. So what y values am I going to get? All the y's greater than or equal to negative 12. It's just the y coordinate of your vertex. Yep. Sure. All right, so what do we think about this? We're okay?
No.
What's the matter?
I don't know. Just not getting it.
Which one? Which part?
Like, when you plug in quotes, I don't know.
The graphing? Wait. How do I know what points to plug in?
Just confused me. How you got the one on the line.
This one or this one?
That one.
This one? Oh, that's your Y-intercept, so don't you plug in 0 for x? That's all. So just plug in 0 for x and see what comes out. Negative 4 comes out, right? Right? If you look at your equation, if you plug in 0 for x, don't you just get negative 4? Yeah. So, buy one, get one free.
There's only 3 different types of these, right?
Yes. And actually, I'm glad that you said that because we didn't even look at an intercept one.
Yeah, so, but for number 2, when I'm looking at it, the vertex would just be negative 3, comma 2, right?
Negative 3, negative 2. It's the opposite of the number that's in there, but that one stays exactly as it is. Let's talk about one in intercept form. I'm so glad that that came up. How could we forget intercept form, our old friend? Mm-hmm. Say you had something like this. This is intercept form. Tell me what you know by looking at it. Tell me what it's going to look like. Give me anything you know just by looking and not doing any math. You don't know where the vertex is here.
It's gonna cross the x-axis at 4 -2.
Oh, you're so close. It's the opposites. This, in intercept form, when you have two sets of parentheses, that's telling you the two places where it crosses the x-axis. It does not give you the vertex. This is telling you it's going to cross the x-axis at -4, because that's the solution from that, and at +2. So, -4, +2. I know it's crossing the x-axis at those two places. So, when you go to answer letter I, the x-intercepts on this one, that's the one you get for free. You don't have to do any math. You already know them. They're at -4 and a +2. I can use this to find the vertex, because where does the vertex have to be? It has to be in between these two. So in between these two is going to be at what, -1?
Yeah.
I just don't know what the y coordinate is. It's -1 comma something, but to find that something, I do the same thing, which is you just plug in -1 and see what comes out. So if I plug in -1 for both x's, right? X, you have two x's, so each one you plug in a -1. So that'd be 3, -3, that's -9 times -2 is a,
-2? Oh, there's.
yeah, it was just in the equation. So +18. So that's way off my grid, but whatever. Okay. So it was at -1 comma 19. 18, just kidding. So, is it down like a frown like we thought it would be?
No, it's up like up.
No, it's going to be down, right? Because it'll have to do this. If I want to find the y-intercept, let's plug in 0 for x. What would come out for y? That would be 4, -2, -8 times -2 is 16.
Wait, how'd you find the vertex?
So I started with these 2 points that it told me it's crossing the x-axis there. The vertex,
So you found what was in the middle.
right, so you have to go halfway in between those 2 points, which is -1, and I plugged in -1, and that's came out with a +18. I think that's all I would need for this one. Then I could answer all the other things. The axis of symmetry, up, down, blah, 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 blah. So, yes. One, I'll actually tell you exactly what's on the test tomorrow so you know what to prepare for.
There's a back too.
Yes. I'll get there. I just want to, while we're graphing, I want to make sure we cover everything that has to do with graphing. Oh my gosh, we forgot something too. Gosh, we just lost ourselves 2 points at least. Hello, this was an inequality.
Shaded.
Oh, yeah, I
Yes, oh my gosh. Another thing I want you to check before you turn in your paper. Go back and look and see, were there any inequalities? I was supposed to do dotted or solid and shading. I can't tell you how many times kids are going to hand it in just like that. We just did it. Well, I did. If you did dotted or solid and shaded, good for you. But we forgot. Should this be dotted or solid? Dotted. And where would I shade if it says y is less than? Below my line, my parabola, so it'd be all, pretty much everything outside the parabola. Okay, be careful, watch out for that. So, your test, I have it right here, see it? Look what's on the front. Oh, graphs, exactly like what you have right in front of you. I ask you the same things, A through I, that's on this paper. They're just different equations. So, there's 1, 2, there's 4 of them.
So it's 4 of each kind?
No. Oh, that's a shame. Wow. Okay, I'm going to tell you right now. Wow. I feel like I should change one of them, but I already printed them. Dang it. I might have you change one tomorrow. Because there's not a single one in Intercept Form. And I think they're easy. Don't you think they're easy? We'll change, yeah, we're going to change one of them to... I can't believe I did that. Sorry. So there's 2 on the front that are in standard form. So 2 just like the first one right here. Just like this. And when I say just like it, I mean pretty much just like it. Then on the back there's 2 just like number 2. Then I have the inequality separate. So then I have 2 that are, you're just graphing the inequality. You're not answering any questions about it. You're just graphing it. That's it. And right now they're both in standard form, but I think I'm going to make one of them, I'll have you cross it out and put in a Vertex, or Intercept Form one. I can't believe I didn't put any on here. What's the matter with me? Then you have 1, 2, 3 questions that are all just like the ones we've been talking about. And I think ones just like that are on the back here. Yes, there's 3 questions just like what you see on the back. So one like this, and then one more. And they all have to do with projectile motion.
Wait, listen.
Yeah.
Say 3 questions and then
Just like this, like this.